Section 2.5 is solving equations using addition or subtraction. Our learning target and what we're shooting for is, I can solve equations using addition or subtraction. Inverse operations are two operations that undo each other, such as addition and subtraction. When you perform the same inverse operation on each side of an equation, you obtain an equivalent equation. Equivalent equations have the same solution. Our subtraction property of equality says that we can subtract the same number from each side of an equation to produce an equivalent equation. So, in our first one here, I have x plus 3 equals 5. So if I want to, I can subtract the same thing from both sides. Here, plus 3 minus 3 just gives me 0, and x plus 0 gives me just x. 5 minus 3 gives me the 2. So this equation and this equation and this equation are all equivalent equations because they all are true statements if we plug in a 2. We get 5 equals 5, the middle gives us 2 equals 2, and our last one would have 2 equals 2. And it works no matter what. So in the second line here, they're all just variables. We can subtract an a on both sides and get equivalent equations as well. So in example 1 here, I have x plus 9 equals 3. I'm trying to get that x to be by itself. So I want to eventually have something like x plus 0 because anything plus 0 gives me itself. So in order to get that to be a 0, I need to subtract a 9. And if I change my left side, I've got to change my right side of my equation as well. Now, when I add those up, I did not change my x. Plus 9 minus 9 gives me 0. And negative 3 minus 9 gives me negative 12. And again, I didn't change the fact that those sides are equal. Now I know that x plus 0 is just x, so I get x equals negative 12. If we want to check that, we plug it back into our original equation. So I have 12 plus 9 equals negative 3. Let's check that. It's a negative 12, sorry. I have negative 12 plus 9 equals negative 3. And I get negative 3 equals negative 3. That checks, so my solution is correct. The addition property of equality says adding the same number to each side of an equation produces an equivalent equation. So just like with our subtraction property, as long as we do it to both sides the exact same, I add a 3 to the left, I add a 3 to the right, or I add an 8 to the left, I add an 8 to the right, we get equivalent equations. So we can use that property down below. Right now I have a minus 11. Remember, I'm trying to get it to be y plus 0 because y plus 0 is just y, and we're trying to get it down to just our variable. So I need to figure out what I can do to the negative 11 to get to 0. Well, addition undoes subtraction, so instead of subtracting 11, I can add 11. And again, if I change one side, I've got to change both sides in order to keep it equivalent. Now, negative 11 plus 11 gives me 0, and 23 plus 11 gives me 34. I did not change the fact that they're equal, and I did not change that y. Now I can simplify. Y plus 0 is just y, and I get y equals 34. Now, to check that, we plug it back into our original equation. I have 23 equals, I see a y, so I plug in my y value. Then I check, are these the same? 34 minus 11 is 23. So I get 23 equals 23. It checks. We are right. We can weigh a horse by putting it on a trailer of a known weight and weighing the horse and trailer together. The weight of the trailer alone is 2,150 pounds. The combined weight of the horse and trailer is 3,375 pounds. What is the weight of the horse? So we know horse and trailer is $33.75. It also tells us that the trailer is $21.50. So I'm going to plug that in for T. So now I have horse plus the value of my trailer equals my total. Now I have addition, so I get rid of addition by subtraction. Because again, we're trying to get that H all by itself. And when we simplify here, I did not change the H. I know that positive 2150 and a negative 2150 are opposites, so they're going to add to 0. I did not change the fact that these two are equal to each other. And now I subtract. And simplify. H plus 0 is just H. So my horse weighs 1,225 pounds. To check it, again, we know that the horse plus the trailer have to equal this $33.75. So when I add these up, I get $33.75 equals that $33.75. So we are good. Feel free to pause here and give this a try. Right now I have x plus 8. I want to get rid of the 8, and I want it to be plus 0. So to get rid of addition, I subtract. And if I change one side, I have to change both in order to keep it even. Think about it like a teeter-totter. Okay, in order to keep the weight even, if you add a person on one side, you have to add a person on the other, or whatever it happens to be. Now, I know that positive 8 and a negative 8 is going to give me 0. So I didn't change my x. I didn't change that they're equal, but I did change my right side. So 19 minus 8 gives me 11. I know that x plus 0, or anything plus 0, is itself, so I get x equals 11. Now, we plug it back in and check. I have 11 for x plus 8 equals 19. 11 plus 8 gives me 19, which equals 19. So that checks, and we are correct. Number 2, I have y plus 13. I want to get rid of that 13 and get it to 0. So if I have a plus 13, I have to subtract 13. And if I change one side, I've got to change both. Now, negative 7 and a negative 13 gives me a negative 20. I did not change my equals. I did not change my y. But I did change my 13. Plus 13 and negative 13 give me 0. Y plus 0 gives me just y, so I get y equals negative 20. Now, we're going to plug that in and check. I didn't change the negative 7. I did change my y to be negative 20. And I didn't change that plus 13. I'm going to go ahead and simplify. Here, I get negative 7 equals negative 7. That checks, so my solution is right. In 3, I have n minus 4. To get rid of a subtract 4, I have to add 4, because that's how I get back to 0. And if I change my left side, I have got to change my right side. Again, I did not change my n, but I did change my number here. Negative 4 plus 4 gives me 0. I didn't change the fact that they're equal because I did it on both sides. And now on my right side, I have a negative 7. We know that anything plus 0 is itself, so I get n equals negative 7. Now we're going to plug it back in and check. My n value was a negative 7 minus 4 equals negative 11. Let's check it. Negative 7 minus 4 is negative 11. I get negative 11 equals negative 11. That checks, and we are right. 26 here, or sorry, 4 here. I have my variable. It's being subtracted, so to get rid of subtraction, I have to add, because that's how I get back to 0. On my left-hand side, I have 87. These are still equal because I did it to both sides. I haven't changed my variable, but I did change my number there. Negative 61 plus 61 gives me 0. Anything and its opposite always add to 0. P plus 0 adds to P. Anything plus 0 gives me itself, using my identity property there. So I get P equals 87. Now, we plug it back in to check. 26 equals that P value we got, 87, minus 61. We simplify here. 87 minus 61 gives me 26. So I get 26 equals 26. Since that is true, our answer is correct. While holding his cat, Doug steps on a scale. The scale reads 161 pounds. Doug weighs 148 pounds. What is the weight of the cat? So here, Doug and his cat step on the scale. And the scale reads 161 pounds. We know that Doug is 148 pounds. So instead of a Doug, a D, I'm going to put 148. I don't know anything about the cat yet, and it doesn't change that their total weight was 161. Now, I want to know what is the weight of the cat. So right now I have a positive 148, which means it's like a plus. I will need to subtract. That's how I get to 0 there. And if I do it on the left side, I have to do it on the right side of my equals. Okay, it's to each expression on the equal sign. When I add these up, 148 minus 148 gives me 0. I'm still have a positive C, so a plus C equals, and on the right side when I subtract here, I get 13. I know that anything plus 0 is itself, or 0 plus anything gives me that thing, and I get the cat weighs 13 pounds. If we check it, and I say Doug is 148 plus the cat, which is 13, I get 161, which matches what I should get. So we are correct. And that's everything for section 2.5.